In part 1, I mentioned that I have undertaken a DNA ancestry test. This involves scanning variation in my autosomal DNA. However, in addition to this test, I have also undertaken a Y chromosome test, which involves scanning variation in short, repetitive sequences found throughout my Y chromosome. In the context of my own family, I am unique because I am the only one amongst my siblings who can undertake a Y chromosome test. And there's a very simple reason for this. I only have sisters, 4 sisters to be precise. So the Y chromosome is passed from fathers to sons like a surname. I inherited my Y chromosome from my father, but I also inherited my surname from my father as well. So let's look at a basic family tree that shows how my Y chromosome was passed down. So there you can see that's me on the left. I inherited my Y chromosome from my father, and he inherited his Y chromosome from his father, and who inherited from his father, etc. But it's worth noting my maternal grandfather, my mother's father, who is circled in red there, he is not relevant. I did not receive a Y chromosome from him because he passed on an X chromosome to my mother. So the Y chromosome can be used to trace your paternal ancestry. Now, thanks to my uncle, who has done some research on my family tree, he was able to trace my paternal line back to my great-great-great-great-great-great-grandfather, Thomas White, who was born in England in the 1600s. Now, when I called my uncle and asked him about some of the research he had done, he admitted he wasn't entirely sure he had all the details correct on this part of our family tree. Things can be pretty tricky when you're researching ancestry that far back, I'm sure you understand. But for the sake of the argument, let's just assume that my uncle got everything right in regards to this ancestor, Thomas White, because I want to use Thomas White as a teaching tool. I obviously have a very deep connection with Thomas White because not only did he pass on his Y chromosome to me, he also passed on his surname. But I can trace my Y chromosome ancestry much further back by undertaking a Y ancestry test. And that's what I did. So I paid for a kit that I received in the mail. And with this kit, it had something to retrieve my DNA, which I scraped the inside of my mouth. And on that it retrieved cells which contain my DNA. And that sample I sent back to the company, and I waited for the results. Now, the company that I utilised has a basic summary on their website as to who can take a Y DNA test. And so under the heading, if you are a genetic male, they make this statement. The Y chromosome is passed down from father to son. Therefore, if you are a genetic male, you can take a Y DNA test and research your paternal line. Okay, that makes sense. Alternatively, under the heading, if you are a genetic female, they make the following important clarification. Genetic females cannot take a Y DNA test because they do not have a Y chromosome. However, if you are interested in learning about your paternal line's ancestry, we recommend finding a genetic male to test, like a brother, uncle, father, or cousin. So there are a lot of different ways that you can waste money, but I would suggest to you that one of the most foolproof is, if you are female, send a DNA sample into an ancestry company and ask for a Y chromosome analysis, because there is a very, very high likelihood that you'll be disappointed with the non-existent results. So in any case, in my case, I waited for 6 to 8 weeks and eventually I received my results, which included a prediction of my Y DNA haplogroup, which is basically the deep ancestral group that I belong to. And in my case, they predicted that I belong to the haplogroup RM269. Now, admittedly, that name, RM269, is not very memorable. It doesn't sound like a good name for a person, partly because it sounds more like the name of a stormtrooper in Star Wars than the name that you'd give a baby. But in any case, RM269 is the haplogroup I most likely belong to, along with millions of other men worldwide. In fact, this haplogroup is the most common haplogroup in Europe, and it peaks in Wales, where over 90% of men belong to this group. Now, another thing the Y-DNA, the Ancestry company, did was that they also mentioned in my results some celebrities that belong to this haplogroup also. And one of the celebrities caught me by surprise, and that was the King of Pop, Michael Jackson. Now, at first glance, you may look at me and not expect me to share a genetic connection with Michael Jackson. And in fact, if you ever saw me try to dance, you'd probably be adamant you couldn't possibly share a connection with Michael Jackson. But there appears to be a logical answer for this. According to the information on the DNA Ancestry company I utilise, Michael Jackson never undertook a Y-DNA test, but one of his paternally related relatives did. What appears to have happened is that many years ago, a slave owner with European heritage appears to have fathered a child with an African American woman. The child born to them was a boy with a Y chromosome that belonged to the haplogroup RM269. And this baby was a paternally related ancestor of Michael Jackson. Many generations later, the Y chromosome in this baby was passed down to Michael Jackson, and that's why Michael Jackson had a version of the Y chromosome commonly seen in men with European heritage. But what I want to do now is I want to go back to my ancestor, my great-great-great-great-great-grandfather. Did I say 7 greats? I meant to. Thomas White, who was born in England in the 1600s. Now, I obviously carry a very deep connection with this man because not only do I have his surname, I also carry around roughly 50 trillion copies of his Y chromosome. I'm composed of roughly 50 trillion cells, and each of those cells contain a Y chromosome. And so this is basically what DNA Ancestry books will tell you, as I quote this one here. Unlike autosomal DNA, Y-DNA is passed down to the next generation largely unchanged and does not recombine with other DNA. The Y chromosome analysed in a living male is virtually identical to the Y chromosome in his paternal great-great-great-grandfather. Okay, well, in the case of Thomas White, we can add a few more greats and a few more mutations, but I am essentially walking around with 50 trillion copies of his Y chromosome. But when it comes to my sisters, things are very different. They don't share the same connection with him that I do. And this is where the difference between a genealogical ancestor and a genetic ancestor comes into sharp focus. In the case of my sisters, Thomas White is their genealogical ancestor because, to put it simply, he's on their family tree. But he may not be their genetic ancestor because he may not have passed down any DNA to them. Think of it this way. You receive about 50% of your DNA from your mum and about 50% from your dad. And because parents pass on a different 50% each time, that's why two siblings can have slightly different ethnic ancestry percentages on DNA Ancestry tests. But in any case, that's what you receive from your parents. If you go back the next generation, you receive roughly 25% of your DNA from each of your 4 grandparents. And then if you go back another generation, you receive about 1/8 of your DNA from each of your 8 great-grandparents. And so you can see that if you continued this process long enough, you would get to a point where you can actually have an ancestor who is a genealogical ancestor, but they're not a genetic ancestor because they didn't pass on any DNA to you. And that is quite possibly what may have happened with some of my sisters, that Thomas White is their genealogical ancestor, but not their genetic ancestor. However, in my case, Thomas White is both my genealogical ancestor and my genetic ancestor because, remember, I'm walking around with roughly 50 trillion copies of his Y chromosome. But my connection with Thomas White goes even deeper than this. And that's because on the Y chromosome that he passed down to me, on the short arm of that Y chromosome resides a gene. And this gene, which we'll look at a little bit more closely later on, this gene triggered male development when I was in my mother's womb about 6 weeks after conception. Now that's what I'd call a connection. So what we've seen here is that the Y chromosome is passed down the paternal line and can be used to trace paternal ancestry. And it actually connects men worldwide. But what I would like to do in the next section is I'd like to go back to looking at both the X and Y chromosomes, and I want to look at genes on these chromosomes and see how they can be used to distinguish between males and females in forensic science.